So for those who don't know us, xbim, been around for quite a while. Three founders are kind of really experts in BIM. I've been at it for about 15 years. My co-founder Steve Lockley for more. You might know us for what's called the xbim toolkit, which is an open source software library used by software developers to read and write the open BIM formats, amongst others. We've also got something called Flex, which is what I'll be going through today, which is an open vendor neutral cloud platform for that partners use to build BIM, AIM, and digital twin solutions. We're more than just 3 folks now. We've got some venture capital behind us. We're a team of about 10, but our scale point is through typically software partners and technologists who work with building data. Just a heads up on what Flex is. So it's a cloud native, developer centric platform. It's a set of cloud APIs that are backed by a really secure enterprise hosting capability. So you can host around the world wherever there's an Azure instance. And it's got modules for really rapidly building BIM and AIM and digital twin capabilities. And it's really around eliminating a lot of the complexity with working with that domain. And as I'll speak to in a minute, BIM's are quite a scary, complex space. And we aim to simplify that and make it much quicker to get products out there. It's all built on open formats, open data, and open BIM. So it's IFC and the like behind the covers. And its purpose is designed to span across contractual boundaries. So from designers to contractors or contractors to clients, at the different phases through a building's life cycle. And just really quickly, you'll see it in a minute, but it's essentially a hosting platform with a number of key modules. The main one is an asset information module, management module. There's also an automation module, which is around quality assuring data coming into that system. It's got collaboration and security features. Clearly it's got a viewer, so you can visualize your asset model, BIM model, or digital twin. And it's also got the ability so you can secure it and integrate it into your software systems, whether that's your users or your software products and your licensing mechanisms. Additionally, it's got some plugins into things like Autodesk Revit and all the Microsoft type software, so things like Power BI. So just as a heads up on what Flex is, and you'll see it in a minute, but you know what I'm talking about now. So really here today, I want to do a quick introduction to digital twins, what they are. And obviously my expertise is in BIM and AIM. I'm not I know digital construction is my space. I've been in it for 15, 20 years. But the digital twins are quite new and quite novel. It'd be my interpretation to some extent, how it interacts. So there's a lot of confusion over is a BIM part of a digital twin, is an AIM part of a digital twin? What is a digital twin in the first place? I thought I'd try and put down my thoughts on these 3 different terms and how they interact with each other. So we've got BIM, building information modeling, AIM, asset information models, and digital twin, which I'll try and define now. So digital twin, according to one of the kind of official references for this, is it's a virtual information that constructs and mimics the structure, context, and behavior of an individual unique physical asset or a group of physical assets. So it's worth noting it's broader than just a construction built environment, and it's dynamically updated with data from its physical twin throughout that twin's life cycle, so that you can realize value. That's probably the most important part. It's not just a fancy game engine 3D view of your facility. It's linked to it. It's linked to sensors and data in that building, so that you can have a feedback loop that informs and builds value in your physical product. So the origins of digital twins probably go back to NASA in the 60s and the Apollo missions. At least they try and lay claim to that. And it's a good argument. They built replicas of their highly expensive, highly dangerous type projects of going to the moon and space missions and so on. And particularly Apollo 13 is a great example where through having a twin of that physical craft in space, they're able to work through problems. They're able to simulate, diagnose, optimize, sequences for how they could get the folks back from a kind of stranded vessel. And you know, while it's a physical a twin, it is very much a mock-up, but it's linked to data. It's linked to the physical machines, the physical crafts data, and they're then able to use that to simulate and monitor and go through a process of it. It's a feedback loop. Without that feedback loop, they probably would have lost them. Clearly, you know, it wouldn't have worked without real-time sensors. It wouldn't have worked if it wasn't really based on the physical device, the physical model. So it's informed by the same design model, even though it's a sort of a virtual prototype. That's the kind of real origins of it in the 60s. Clearly, aerospace and the like have picked up digital twins in engineering, whether that's on the components like jet engines, or it might be on all the aircraft systems or navigation systems. Quite often there are, you know, you go into Boeing, there will be a twin of that 777 aircraft that they can use to simulate and optimize. And I think the same would be true if you go into any advanced racing Formula One type team, where there is a twin of that physical car, because it's high value and you can't always be on track. So you want to simulate it, and you want to simulate whether it's components or simulate systems, or a wider concept of a whole race. And that kind of concept, but you know, it's probably worth noting that a digital twin can occur at different levels. So it might be a component in that twin, it might be a more higher level asset or a system, or could be something much wider again, which might be looking at the wider process, whether it's construction or if it's a race or whatever. The twins used really broadly, and clearly, you know, in the construction industry, we're not sending people to the moon or flying jets around the world, but we have got really high value assets, and we've also got assets that, you know, have a major impact on society, are really costly. You know, lots of people work in them, need a good experience, need a decent environment to deliver the services that they're in there for. And so this is where building digital twins are coming in. People, you know, we want to provide high, you know, safe spaces to work in, hospitals that have, you know, a great availability and great key KPIs. And it might be down to, you know, and if you don't measure it, how do you know how do you improve that condition or that indicator? That's where digital twins are coming in. I thought this was, you know, there's a myriad of use cases for digital twins in buildings. I've got memory here, came up with a fantastic I guess diagram of different use cases of smart buildings in particular. If you haven't seen it, go and look up memory. They've got a great report on this. And they're looking at, you know, smart buildings through a number of different lenses or lines, whether that be the business enterprise, whether it be the people in those buildings, or if it be, you know, things like energy usage or security and safety of that building, which is obviously a key topic, and we'll perhaps talk about Building Safety Act and the like in a future webinar. But there's many reasons for a digital twin, or for needing one in a building. It typically, you know, how can I improve the outcomes and the efficiency of that building? You know, and perhaps as an asset owner, it might be around the condition and overall value of my estate. Again, twins are at different levels, so they can be down to, you know, a component twin, you know, perhaps an air handling unit, or just sensors in a room somewhere. You may be interested in actually, you know, occupation within a room or so on. But more broadly, you tend to be looking at systems, which is groups of these components, whether that be a heating and cooling system, or you know, a hospital might have a hospital ward you want to look over. Level above that, you may want to look at buildings, the whole building, or a whole piece of facility. It might be a bridge or a railway line or something. And lastly, you know, at a business level, you may want to have a complete enterprise and portfolio view over all that the goings on in those facilities under your command. That's my kind of my overview of digital twins. I'm just going to break down now where BIM and AIM fit into them. I'm going to start with BIM, which is at the bottom of the stack. Most, I think, will know us, which is our kind of area of expertise. BIM really is defined as a digital representation of a built asset to facilitate design, construction, operation, and the processes to form a reliable basis for decision, particularly during construction, but also increasingly into operation. And it's worth noting that BIM data is complex, and like many domains, like many industries, but BIM has its complexities. They are really databases. When you get a BIM file, it's a database behind the scenes, really. And from those databases, often what we're generating is something you can see, a visual, in 3D. Often it's schedules of data, registers, assets, spaces, risks, or whatever. And it's documentation, drawings, and artifacts. And often BIM is the origin of those sorts of information. And so, you can imagine all that information is useful in a twin. It can be valuable, but there are some challenges with all that. I'll talk to some of these today. Some of them I'll just mention. Proprietary formats is a key challenge here, is that information in BIM is quite often a proprietary format, hard to access. You need to get the licenses for it. And actually, there's some longevity challenges with a proprietary format. But also there's an issue around complexity. And these are, the domain is for construction of a building, and it is complex. There's also challenges around data quality. And then the last two got to speak to the fact that these models are typically built by a supply chain, different, I guess, experts in different segments, providing data in slightly different ways. And the collective of it all is it's a big set of data. It can be gigabytes and gigabytes of data, which might not be appropriate to a digital twin, where you want a slimmed down version. And this really speaks to the fact that BIMs are a bit of a hairy dragons, a scary space in terms of a data set. If you're going to build a digital twin in a service, BIM's a logical data source, but it's also complex. Just to give you some insight into that, if you go and look into something like Autodesk Revit, how they categorize some of their different concepts, they range from, in this case, is the bottom of the list, but roads and roofs. We've got things like stairs. Okay, we understand all that. The whole series of concepts around structural entities within a building. Some more, obvious things like walls and windows, but vibration management. It's broad and it covers a lot of domains. And if we go and look at the Open BIM domain, the IFC domain, which is where we work a lot, again, it covers an increasingly large array of different concepts, and so all of which can have digital twins. We have digital twins of railways and roads now, ports. But if you look, there's all kinds of, this is the architectural diagram of the Open BIM domain, and behind each of these is a dozen or hundreds of different concepts. So hiding behind shared building elements, which is a kind of shared layer, are kind of common things that go into a building, like walls and doors and windows and so on. And below that are what's called low-level concepts of dates and materials and people and that kind of thing. But if you go and look at one, and this is almost designed to just give you an idea of how complex things get quite quickly, if you're interfacing with a BIM, is something as simple as a door has quite a complex set of relationships with its object models that ultimately result in that door having a really complex set of structures in terms of its semantic data and its geometry data. So just that, I want to look at a door, suddenly you've got quite a bewildering set of options. So this is all really leading up to saying, actually, BIM is quite a challenging space to work with if you want to suddenly integrate that into a digital twin. So I'm going to move on to AIM, asset information models. And really, this is about compiling all the required and validated data that you might need, information, documentation, and so on, to support ongoing management and operation of an asset in its use. So this is for a client. Typically, a client wants an asset information model or a set of them. They've got lots of buildings. And really, my argument here probably would be that probably a more appropriate model to start to use for your digital twin than the source BIM, or at least it's an easier model to work with if you were to build a digital twin. It's a less of an overload on the in terms of systems and just conceptually. So what's an AIM? Well, just to sort of step aside to a different industry, into the motor industry, and that's, if you think around cars, clearly they're designed very detailed, very sophisticated engineering processes in those factories. If they go into a Porsche workshop, I'm sure they've got some amazing technology in there that builds a Porsche. As a owner of that, if you're fortunate enough, you can own a manual, and it might tell you how to go and change the tire or change the oil. It's built as a manual operating that facility. You're going to get your Haynes manual, it might give you a bit more detail, but it's a much more simple set of documents, and it's user focused and business focused. Interestingly, these very analog paper manuals are getting digitalized. This is a Hyundai app, I think, but you can take your smartphone now, show it your bonnet, and it will flag up, here's the air filter, here's how you change it. So they've digitized that. It's not a case of thumbing through an old manual. They have a digital asset information model that you can use, and that's what's going on in the construction industry. I think most of us know this. Clients will get an asset information or an operation and maintenance handover record at completion. It's still often paper-based or PDF or on a stick, USB stick. This is a particularly neat one. In reality, it's a fairly unstructured set of documents, and increasingly clients are being mandated, or not mandating, but they want something more digital as a record. So this is where AIM comes in. AIM being a collection of data, geometry, and documents. Okay. Most commonly, what you may hear of COBie as a handover format for operations and maintenance. And you'll see from that little diagram of COBie here, it's a much simpler domain than working with a BIM. So it looks as a facility, as having floors and spaces. In those spaces or rooms, there may be components which may be defined by a type. And you can put components into groups and call them systems, and you can put the spaces into zones, which might be kind of, sub-tenancies or whatever. And with that comes, this is about as large as the domain gets, pretty simple. And ultimately, that's a set of contracts and a set of kind of concepts that we've adopted in xbim Flex. It's an AIM model that looks at your building, and it represents it as a set of levels and spaces and components with data. So that's an AIM, and I will say probably with BIM there were standards. AIM, there are some kind of ISO 19650 standards, but it's a little more, and there's things like COBie, but there isn't actually a one true AIM. It's probably more semantic. So put this all together, tying it all together, my view of kind of digital twins or buildings at least is that there's kind of two main aspects to them that need to work together in concert. There's an asset information model and there's operational data. And asset information models typically are, nice thing, if you've got a BIM model, they can reuse that. But also in theory, you can build an asset information model from scratch without a BIM. Whereas the operational side, obviously what the key thing is sensors, real-time data, having a history of that data, being able to analyze it in some kind of data warehouse, and perhaps combining that with some of your operational business data. And ultimately, what we're trying to do here is take operational data from your facility, make sense of it through the lens of an asset information model, which is a register of what you've got in that building, whether it's components or people, and perhaps the audit trails with all those physical elements, documentation and so on, and creating a feedback loop between those. So perhaps as you're informing changes to your building through looking at a digital twin, you may perhaps want to change the way you are deploying a particular ward in a hospital to make it more efficient. You should be updating the AIM record and records with that. And so I think there's probably two parts. One, they don't really work if you've only got one half. You've only got the AIM, not a digital twin, and you've only got operational data. It's hard to call it a digital twin, in my view. So I don't know if there's any questions so far. What I'm going to do is go into a quick section on just, lastly, I'll just quickly talk about openness, and then we'll go into a demo. So what I've talked around in terms of that feedback loop is probably an important point, that as a digital twin needs to be, or an asset information model needs behind a digital twin needs to be maintained for the life cycle of that building. And buildings you're putting in the ground today are probably going to be in use for the next 20-30 years minimum. It means that data is going to be maintained for the next 20-30 years. And so really, how you've got to think, how will you maintain that data and open it in 30 years' time? And there's a challenge to that, and really one of the answers to that is to make sure you've got it in some kind of open standard, rather than being beholden to a proprietary standard for the next 30 years. The clients are mandating this these days, because it's all very well having a Revit 2020 model, but are you going to open it in 2050? It's unlikely. So we're through really about open standards, open BIM. And I believe it's probably best for clients in the long term, because that information means they can own it, maintain it, and manage it, and pass it on through the life cycle of that building. So what I'm going to do now is take you through a couple of demos of Flex, which is an asset information model kind of server, an AIM server. These are some videos. Just bear with me. I'm just going to quickly flip the resolution up so we can see it better. So I'll just pause that. What I'm showing you here is our Revit add-in. And this is an add-in into Autodesk Revit that lets you take BIM data out and put it into an open BIM form and put it into an AIM in really quite a simple set of steps, and it's a repeatable set of steps. So you can take a complex building model. This is a federated building model, and extract things like floor plans, drawings, schedules, asset registers, all the semantic data, all the 3D data, and a lot of the documentation from that model, and extract it into a form. At this point here, it's open BIM. It's turned it from being a proprietary data source into an open data source, and it's turned it into an AIM as well. So what's smart? So what you're seeing here is, okay, we've just clipped on the first floor. So we're clipping taking a drawing, clipping the building to the first floor. So the 3D model is linked to the drawings it comes with, and that creates quite a nice way of navigating a building and making sense of it. And it's come through with data. So in this case, look at that chiller. It's got a set of essentially COBie data, operational data, whether that's warranty, parts, costs, dimensions, who the manufacturer was, that we can inspect dynamically. But I can also, as you'll see here, bring up a list of what we call a schedule, which is just a table of data. In this case, it's a table that comes straight out of Revit that is COBie-like data, and it can be shown in a COBie table. And it's interactive again, so I'm picking spaces and highlighting. We can see where they are in the facility. I can also click spaces in the model and highlight them in this data set. If I'm going to find here, I think the mechanical room, we'll highlight where that is. We'll go and find it on the floor. And we can then, what we've got here is a fairly simple view of, it's a set of spaces that have components that are within those spaces. So we'll see within this mechanical room in a minute, it's got some air handling units, and there's some data behind those air handling units. So it's a whistle stop. How do we get data into a platform like Flex? What you're seeing here is one of our applications, but actually often this technology ends up being white labeled into other people's products or your product as an organization. So that was just a quick demonstrator how we get data out. Let me go put the quality up again on this. So this here is just to quickly pause it. It's exactly the same data, exactly the same model we pushed out from Revit, but it's sitting in a different application. It's much more of an AIM Explorer. So this is showing us that same facility. There's some information about that facility, its address, it's kind of where it is in the world, some things about units, and it's showing we've got, for instance, there's a couple of floors and 268 rooms. And then we've got some breakdown structures that are floors or levels and rooms. In those spaces, we'll find them linked to components. Components might be linked into systems. We've got some documents. And behind the scenes are other concepts of spares and resources and jobs and those kind of things. So just quickly, this is really a demonstrator application, but all it's doing is speaking to our API and just showing what's in that building model really quite simply. So first up, clicked on some levels. Just flagging these different modules we've got in or different domains that are in the asset information model. Going to do a quick demonstration of how you can filter data. So I've just found all the accessible floors, that's floors that have got doors on them. You'll see, for instance, floor 2's got 109 rooms on it. And then we also managed to automatically clip that building so you can see a floor plan. And then we're going to look at that machine room, double click on the machine room, and it's going to take us to a space. So now we're in that mechanical room. And we can see that mechanical room is in zones. We see some documents associated with that mechanical room that you could add to or amend, or add your own documents. Might be floor plans, might be room data sheets. And then we're seeing all the information that's tagged against that space. And this tagged data is also searchable and queryable for a really simple API. So I think I'm going to quickly show you that. Here we're looking at all the rooms in the facility, and bringing in the areas and bringing in a classification. This is a US test model, so it'll have a US classification system. But saying, okay, go and find me everything, all the rooms that start with mech. And then we've identified the mechanical rooms. So they were classified as a mechanical room. And we can pick either of them, inspect them. And then perhaps to show you, we could filter on something like the area. So we want to find, the larger mechanical rooms, or you may want to find the rooms that have got an air handling unit in it. You can ask those kind of questions. Quickly going into zones, just to quickly show what's, so zones are collected as spaces. So here's a zone that was created that is all the mechanical spaces, the plant rooms. It's got 3 different spaces in there. As I selected it, it's highlighted them. But this is a use case where we can create new data. So in this case, what we do is create a new zone. Let's call it COVID secure. And then we can associate that new zone I've just created with some spaces, save that, and then that can be recalled and reused in use cases in future. So that might be, again, I'm zoning a building off into different rooms or different tenancies. So it's worth noting, that means the aim is a writable database there. It's not, you haven't got to go back to the Revit to make that change. Here, just going into the components now. So we're listing all the components that are in that facility. Search for chiller. I could have done that by a variety of means. I just typed in chiller and it found it. And again, listing all the kind of, the attributes that came in from the BIM that may or may not be useful in a digital twin, whether that's, voltage or warranty dates or when it was last inspected. And lastly, I think what I'm going to do here is filter through again, a similar thing. So we're going to find all the assets that are in my building that are classified. Again, it's an omniclass classification, but in the UK it might be a uniclass. So find anything mechanical or to do with HVAC. Again, so there's a couple of hundred HVAC components in there. We can pick and inspect and find them. Similarly, let's go into types. So types are a family, so they're a grouping structure. So we found all the tropper lights in there, clicked on it, and it's highlighted every single element that was of that family. And lastly, I'm going through the systems. So we found a mechanical system here. So it's mechanical return, selected it, and it's highlighted all the 800 or so components that make up that system. And it knows how they're connected and joined. And behind that system, we can drill in, look at individual components, documents, data about that system, and use that as though it were, a more complex asset, a complex single item. Here I'm just drilling through to one element. So it is that air handling unit that's in the mechanical room. And you'll see it's got a type, which is its kind of family. And it has a series of data against it, which I showed you earlier. Lastly, I'm going to documents. I think we show you a drawing really quickly. But what happened there was the documents, we listed them, and those documents are linked to items in that asset information model. So what that means, they are, if I go and look at the, come back to this. As I go and look at that document, I know it's associated with an asset or a space or a type or a system. It's a relationship it has. It's not a document that's on its own, unlinked. So I've shown you some sort of pre-canned demos there. I will, Matthias, I'll be sharing this deck afterwards so you can see that video again. So just to speak of a couple of other things, I haven't got a video of this, but you saw how earlier we were adding zones. We can also add documents and systems and those kind of things to the model. We can also edit data that's already there or add new data. So for instance, we might want to capture a serial number during commissioning, an asset tag or something. And so it's a writable data model. Once the BIM has been turned into an AIM, it becomes a master record. And in this case, we can go in and create a serial number and an inspection date and link it to that twinned component. And that's all linked with an audit trail and access control and permissions and so on, so that only certain people can do that. And if we want to go and look at this in future, we can see, who changed it when, what's the value previously, and so on. So it creates it doesn't mean you don't have to go back to a BIM authoring tool to make sensible in-use data changes. And it'll be linked. If I look at that file extinguisher, it will have a serial number associated with it. How are we doing for time? Lastly, I want to quickly talk about portfolio. A lot of clients, particularly if you're talking high-end clients, have got many properties. They might be because they're university estates or hospital estates, schools, data centers. It's not about one BIM or one building. It's about looking at my portfolio. And the Flex platform is built as portfolio centric. It's meant for a client to be able to look at it across all of their assets, and they'll see the data across everything they've got the rights and permissions to see. One of the things I'm going to show you here is we're bringing that together into a Power BI dashboard. Power BI is a kind of a data mashup capability. I will quickly show you this live. If I find the right window. So this is Power BI on the web. It's speaking to a different Flex workspace, but tell you what we've got in here is our viewer. We are looking here actually at a university estate. I flick to this tab here, it becomes more apparent. This is Northumbria University. We've got an association with, got the models of. And so we're looking at 13, 14 different building models, all co-located in kind of space. That's kind of see the real world from Google Maps. But we've got analytics going down to buildings, to floors, to individual spaces. So we can start to say, okay, on the ground floor, show me where all the corridors are. If I can show you that in here, it'll make more sense because we haven't got the walls on. I can go in here and say, well, let's go and see where all the corridors are, or where all the ground floor WCs or whatever. And you'll see here we're going to kind of color coding and looking. Okay, there's 26,000 square meters of gross floor area that meets the criteria of ground floor across the university estate. But if we were only interested in academic offices, we'll be filtering it down to this particular building, 581 square meters. And that's going to, clearly this is not a digital twin as much because there isn't any sensor data in here, but something like Power BI is fantastic for mashing together lots of different data sources and bringing in, maybe sensor type data from a IoT stream or a data warehouse or some other kind of business data you have, and using a tool like this to make sense of, what does that mean across my estate? That's Power BI and I guess to some extent portfolio. Clearly you could be looking at this through a different lens. This is the same spatial information that's shown as more of a chart-based concept. So I think I've covered quite a few use cases today. Just to recap a few of them, I'll send this deck out so you can read them. But really, what we've got is an AIM platform. It's a really useful skeleton on which you can hang other data off. If you've got IoT data, it can make a lot of sense of where is it, what does it mean, where is that out of exceptional data coming from, or if I'm looking at energy users across a portfolio like a university, where are we spending it, where is it? I've shown you how you can also keep data up to date, amend it, whether that's things like renaming spaces, adding new data, creating zones and creating new areas within my organization. And ultimately, it's about taking all the data that's locked up in BIM and making it more accessible to end users, to stakeholders, and being able to bring it into your business and not lock it up into just the facility manager's office. That's all I want to show on Flex. Just a quick last few things on. We quite often deal with organizations who want to go and build their own a digital twin type service. And clearly they looked at us in terms of, could you provide a BIM and an AIM solution with document and drawing management as well. But there is another side to it, which is that operational data. And there's a whole, we don't provide that, but we integrate with that kind of capability. So there's a lot of different providers out there, whether they are the big boys like AWS and Azure, who've got their IoT hubs that manage streams of data and can give you sensible analytics that you can then bring together with a platform like ours to make sense of that information. And there are also specialists in the domain like OpenBlue, IoTech, and the like, who the complex world in here is how do you deal with a myriad of different sensors and data that's coming out of your sites? How are you speaking to all of them in their different protocols and different standards? And there's a whole middleware industry out there that takes some of that pain away. And clearly there's also a physical investment in devices and so on across an estate that needs to be made. But I think we've got some of the building blocks. But if you're looking to build a digital twin solution, I think we're a really valuable service in there that will make sense of this stream of data that's going to come off these buildings. Without it, it's quite difficult to make sense of it. So just going to wrap up. I think we've got a couple of minutes left. Just in summary, I've kind of taken you through our view of kind of digital twins and perhaps where BIM and AIM feed into those. Showing you briefly how we BIM's a complex domain, but we can unlock it. We can get there's value in that data, and we can extract it, particularly when you've turned it into an AIM model, when it becomes more of a maintainable set of data and a set of data we can validate and police over its life. Showing you a little bit about how you might bring some of that data into a digital twin. I suppose my call to action would be those of you on the call who perhaps are in technology businesses, ISVs, and the like, who are looking to build a digital twin service. Feel free to reach out to us, and we'll give you a more detailed demo or flex on what we do.